I would like to clarify that in this presentation we're not doing actual programming. I give you examples of code, which sometimes contains a few lines of code, but I'm just giving you examples of the type of memory allocation and memory use that could be possible during the execution of your program. Over here, of course, we have a program that first prints this on computer screen and asks the user how many characters or how many numbers would you like to create dynamically or allocate. And we create an integer variable counter. And the SYN character input device allows us to read information from the keyboard. So we store it in the counter variable. And then we proceed to this line where we use free store by using the new operator, which is a C++ dynamic memory allocation operator, and ask the system to give us this many integers. And so this is not a conceptually interesting program. It's just demonstrating how you would ask the user for a specific number and then allocate a number of integers in computer memory, integer variables in computer memory that corresponds to the number specified by the user. And then, of course, like I told you, it returns back the memory address where this block of memory is allocated. So this new operator right here, it allocates this block of memory and returns the address right here, the address where this memory begins. And on the next line, we print this address and display it to the user. So of course I would encourage you to just simply copy and paste. This is all portable code. We can just press Ctrl A to select everything in our program right here. Then say build and run this program. So how many numbers would you like to allocate? 100. And here you go. So it on this line right here, I am printing this information. This memory block is the address of this memory that was allocated for us, and it displays that your memory block begins at address such and such. By the way, this is a hexadecimal number, which we will discuss soon in our next videos. Now, I would like to tell you that most of variables in most of programs are called local variables because these are the most used types of variables. So any memory allocated directly inside a function is called a local variable. So we normally, what this does is that we have to choose the data type, integer, character, floating point number, then specify the name of the variable, and it is desirable to also provide the initializer and specify what the initial value of this variable should be. So what happens is that then if we have this memory allocated somewhere in the stack, remember we said that local variables are allocated in the stack memory, which I'll show you right here. So this is our stack area right here. So somewhere when this function begins to execute, this block of local variables is allocated right here by this opening brace. And this variable count will be stored in this area on the stack. So here on the stack, this will be the location of our variable. And when this function f, this is an example of function named f, when it finishes its execution, and so it's a stack frame where this counter variable is physically stored, when it finishes, and this is indicated by this closing brace will actually destroy this stack frame and return it back to the operating system. And this function will finish and return back to its caller. So this is you can see that the life cycle of local variables like this count is limited for to the duration of a function call. When the function execution terminates, the local variables like count are destroyed and their memory is returned back to the system. And of course, just like we did over here earlier, this is another sample where we have an integer x equals 4. And here it's using print function that prints this value. Actually is printing the address of variable x. But nevertheless, this is an example of a local variable that belongs to function main. And we say that local variable always belongs to a function where it was allocated. So for instance, here counter belongs to function f and x belongs to function main. So once again, this example right here, if I copy and paste this also into our compiler window right here, and if I press build solution, and I press Control F5, or you can choose a debug, start without debugging, just Control F5 to execute this, you see that once again the ampersand sign in front of the name of the variable is asking the variable where is your address. And you see that in my case I create this variable, initialize it to 4, and it gets stored in as a local variable in a stack frame that belongs to function main. And you see that when I'm printing it, it's located at this memory address, and it is showing up as a hexadecimal number. Like I said, pretty soon we're going to start talking about hexadecimal numbers.